One last thing regarding logarithms needs to be remarked on, and that is, how do we solve an equation if we have a logarithm that includes a variable? Right, we already know what to do with the log of a number. That's just a number. But if we have a variable in our logarithm, what do we do? Well, this is going to be a very familiar procedure by now. If we have an equation that includes a variable in a logarithm, we'll isolate the logarithm, we'll rewrite the equation in exponential form, and then we'll continue solving normally. Let's see an example. Suppose we have this equation. 2 times the log base 3 of x equals 8. First we'll isolate the logarithm, divide both sides by 2. Then we'll rewrite in exponential form. The base of the log is 3, so the base of the exponential should be 3. The result of the log is 4, so the exponent should be 4. The argument of the log is x, so the result of the exponent should be x. And now I continue solving normally. This isn't real interesting, is it? We just figure out what is 3 to the 4th? It's 81, and that's our solution. Let's see one more example. We have the log base x of 32 minus 3 equals 2. So to isolate the log, notice there aren't any parentheses around the 32 minus 3. So to isolate the log, we need to get rid of the minus 3. So the log base x of 32 equals 5. Rewrite in exponential notation. My base will be x. 5 is the result of the log, so 5 is going to be the exponent. 32 is the argument of the log, so it's going to be the result of taking the power. We have a number to the 5th power equals 32. We know how to undo the 5th power, right? The opposite of the 5th power is the 5th root. Do I need to be worried about plus or minus? No, I don't. 2 reasons. 1, x has got to be positive. 2, this is an odd root anyway. So x will be 5th root of 32. I'm going to say 5 math x root 32 is 2. Maybe I knew that also. So my x is 2. Let me give you a couple of these to try. Solve each of these equations for x. Pause the video and try this now. Alright, log base 3 of x minus 7 equals 8. So first I need to isolate the log. I'll add 7 to both sides. Now I rewrite in exponential notation. The base is 3. The result of the log is negative 1, so the exponent should be negative 1. The argument of the log is x, so the result of the exponent should be x. 3 to the negative 1, that's a third, so my x is 1/3. 2 times the log base x of 25 is negative 4. Well, I'll divide both sides by 2. That isolates the log. Now I rewrite in exponential form. X will be the base. Negative 2 will be the exponent. And the result will be 25. Let's see if I can do a negative 2th root. That seems weird, but let's see if I can do it. I'm going to say negative 2 root x, 25. Yeah, that seems to have worked. Convert that to a fraction. It's 1/5. That was easy. So the claims I'm making are that the log base 3 of 1/3 minus 7 will give me -8, and that 2 times the log base 1/5 of 25 will give me -4. And if I'm not sure about either one of these answers, I can go ahead and calculate this and see if it works out.